Okay, so let's take a look at some very common, right, integration type problems that you might see on the IB exam. Okay, so let's take a look at this question here. It says find f of x given that the derivative of f is equal to 4x times e to the x squared minus 9, and they also tell us f of 3 is equal to 7. Okay, so basically we have the derivative and we're trying to find the original function. So whenever that's the case, we know we need to integrate the derivative, right? So we integrate the derivative, which is 4x times e to the x squared minus 9, right, dx. If we integrate this, it should give us, right, f of x. Now, looking at this problem, this is a clear u sub substitution type problem because this integration here, it doesn't fit the integration table, and there's no way for us to algebraically manipulate this so that it looks like something that's on the integration table. So when you see this, you have to recognize that, oh, this problem requires u substitution. So what I'm going to make the u is this exponent for the e, right? X squared minus 9. So if I take the derivative, du is going to equal 2x dx. So du over 2x is going to equal dx. Now, since dx is equal to this, I can substitute it here. So then we're going to get 4 times x e to the u power, right? Because our u was this exponent for the e. And then instead of dx, I have du over 2x. So now you notice here, it looks like everything is good. The x's are going to cancel, which is what we exactly want, right? The 2 and the 4 is going to simplify. 2 is a constant, so I can pull it outside the integral. So I pull the 2 on the outside, and then I'm going to have, we're integrating, right, just e to the u power du. Now remember, we cannot integrate until everything is in terms of u. So this problem here looks like everything is perfect. Everything is in terms of u. So now the last thing I'm going to do is I'm going to integrate this. So I'm going to have 2. The integral of e to the u is just e to the u itself plus c, right? So this right here is equal to f of x, right? Now they gave us a value earlier. F of 3 is equal to 7. Now remember, this is kind of like, think of it as your x and your y, right? So 3 and 7, so that means I can substitute these values to find the c. So that means this is 7, right? Now I have 2e. Now our u was x squared minus 9, so you want to plug that back in. So we have x squared minus 9, x squared minus 9 plus c is equal to 7. And then the x was 3, right? From our coordinate earlier. Remember, x is 3, and then the y should be 7. So when the x is 3, I'm going to plug that in. I'm going to have 2 times e. 3 squared is 9 minus 9, plus c is equal to 7. 9 minus 9 here, sorry, I wrote a 1 there. 9 minus 9 gives you 0. Anything to the 0 power is 1. So basically we're going to end up with 2 times 1, which is 2, plus c is equal to 7. So c is equal to 5. So our function is going to be f of x is equal to 2 times e to the x squared minus 9. And then instead of plus c, we know c is positive 5 now. So this is our function. Okay? Okay, let's take a look at this next example here. So they're saying the integral of 3 over 3x plus 2, or dx, is equal to natural log k. So first we're going to integrate this right here. So first of all, I see this constant, this 3, I can pull it out. So I can think of this as 3, and we're integrating from 0 to 6, 1 over 3x plus 2 dx. And we know this is supposed to equal natural log k. Now, so you need to recognize from this, right, if I integrate this right here, this is going to give me a natural log, right? And then I also see right here, I have this value in front of the x. So I know when I integrate this, so first of all, I have this 3 here. That's already here, right? Now, when I integrate this right here, since there's a number in front of the x, this is kind of like when you're integrating in terms of f of ax plus b. So we have to start off with 1 over whatever this number is, which is 3. And then when you integrate this, this is natural log, right? Absolute value 3x plus 2. So this is straight from the integration table for the integrating in the form of f of ax plus b, right? So this is going to equal natural log k. So if we simplify this, the 3's just cancel. So we're going to end up with a natural log, basically 3x plus 2 is equal to natural log k. And now we're evaluating from 0 to 6, right? So we're evaluating from 0 to 6. So you're going to plug in the 6 here. So you're going to get natural log, all right, 3 times 6, that's going to give me 18 plus 2, so that's 20, right? Minus, plug in the 0, we're going to get natural log, all right, 3 times 0 is 0 plus 2, so that's 2, right, is equal to k. So using natural log properties, this is the same thing as natural log 20 divided by 2 is equal to natural log k. Oops, natural log k. So we're going to end up with the natural log of 10 is equal to the natural log of k. So we know k is equal to 10. Okay? All right, so let's take a look at this next example. Now, if you've never seen a problem like this before, these can be a little bit tricky. So now, first of all, this is really important. It tells us consider a function f of x such that if you integrate f of x, right, from 1 to 5, our answer is going to be 6. Okay, so they give us this information. Now, part A says, okay, so find the integral of 1 to 5 of 2 times f of x dx. So now, part A here, you notice this is a constant, so I can always pull this outside of the integral. So we have 2, and we're integrating, right, f of x dx. Now, we know what this means, or sorry, not what this means, but what this equals, right? That we're told right here when you integrate, right, from 1 to 5 of f of x, right, it equals 6. So basically, this is just going to be 2 times 6, so our answer is going to be 12. All right. Part B, so right here, this one's a little bit more tricky. So you're integrating from 1 to 5 of f of x, all right, plus 3 dx. Now you can think of this and rewrite it as separate integrals. So this is the same thing as this problem is the same thing as integrating from 1 to 5 of f of x plus integrating from 1 to 5 of 3 dx, right? So dx for both. So we know the answer to this already, right? We're given that up here, so this is 6 plus. Now if you integrate 3, that's going to be 3x, and we're going to evaluate from 1 to 5. So you need to work that out to see what that's going to be. So 3 times 5 is 15 minus 3 times 1 is 3, right? So 15 minus 3 is 12. So 6 plus 12, that gives us 18. So that'll be your answer for part B there. Okay? All right, so let's take a look at this problem here. So we're given that f of x is equal to the integral of 8 over 2x minus 1, all right, dx, all right, when x is greater than 1/2, the graph of f passes through this point, okay? So we need to find out what f of x is. So first of all, this 8 is a constant, so I can pull this out. So if I integrate, right, pull the 8 out, I'm just integrating 1 over 2x minus 1 now, dx. So you just have to recognize this is in the form, all right, of a f of ax plus b. We're on the bottom here. When we integrate this, we're going to end up with a natural log. So you just have to recognize this from the integration table. So first of all, when we integrate this 8 is already on the outside. So times, now if you have a number in front of the x, you always start off with 1 divided by whatever this number is. If we integrate this, we're going to end up with a natural log, absolute value, whatever this is right here, 2x minus 1. And then we have plus c. So we know this equals f of x, right? So the 2 and the 8 simplify. So we end up with 4 natural log, basically 2x minus 1 plus c is equal to f of x. And since they give us this coordinate, this is our x and y, we can plug it in here to solve for the c. So we have 4 natural log 2x minus 1, all right, plus c is equal to f of x, which is 5, and our x, we can substitute that with 1. So 2 times 1 is 2, right? So we're going to end up with 2 minus 1 is 1. So 4 times natural log 1. So you have to think, e to what power will give you 1? It would be 0. So 4 times 0 here plus c is equal to 5. So that means c is going to equal 5. So our function f of x is going to equal 4 natural log 2x minus 1 plus c. Now c is 5, so plus 5. All right. Let's take a look at the next example here. So the graph of f passes through the point natural log 2 and 15. We're given the derivative of f is 9 times e to the 3x power. We need to find f. Okay, so to find f, we need to integrate the derivative, which is 9 times e to the 3x dx, right? And if we integrate this, so first of all, there's 9, we can pull it outside the integral. So we're just integrating e to the 3x power dx. So when we're integrating this, so since we have a number other than 1 in front of this x, this is like the integration table for f of ax plus b. So we have 9 here times, so since there's a number other than 1 in front of this x, we start off with 1 over this number, right? And we integrate e to the 3x, that's just e to the 3x, and then plus c is equal to f of x, right? And then this is our x and our y. We can plug it in here to solve for the c. So this will first of all simplify. So we're going to end up with e times e to the 3, right, times natural log 2, all right, power, right, and then plus c is equal to 15, right? So we need to do a little simplification here. So if you move this, all right, to this, all right, exponent spot, so basically we end up with 3 times e to natural log 2 to the 3rd, which is 8, right, plus c is equal to 15. So here's where you need to remember those natural log properties. E to the natural log, right, power, basically these are just going to cancel each other out and your answer is going to be 8. So 3 times 8 plus c is going to equal 15. So that means we get 24 here. So c is going to be minus 24 to the other side. You're going to get negative 9. All right, so c is negative 9. So our f of x function is going to be f of x is going to equal 3 times e to the 3x power minus 9. Okay? Okay, let's take a look at the last example here. All right, so we're given f of x is 8 over 2x minus 3. And they want us to find the area of the shaded region. So basically we're trying to find the area under this curve. So you have to understand that that means we're trying to find the integral of, all right, we need to integrate f of x, right, from 2 to 8. So from 2 to 8, we're integrating, right, whatever the f function is, because we're finding the area under the f function. So 8 over 2x minus 3 dx, right? So first I could pull the 8 out to the front. So we have 8 here, and we're integrating 1 over 2x minus 3 dx. Now when we integrate this, we just have to recognize this is in the form ax plus b, and we have this number here that's in front of the x. So we have the 8 here, and when you integrate this, you're going to start off with 1 over whatever this number is, which is 2. And then when you integrate this, you just have to remember it fits the integration table, and we have natural log absolute value 2x minus 3, all right, plus, well, we don't need the plus c because we have the bounds of integration. All right, so we're integrating, and we're going to evaluate from 2 to 8, right? So the 2 and the 8 simplify. We have 4 here, so we have natural log, and then we have plug in the 8. 2 times 8 is going to be 2 times 8 is 16. 16 minus 3 is 13, minus bracket, same thing, or you get 4 natural log. Then we have 2 times 2, which is 4, minus 1, which is, sorry, minus 3, which is 1, so natural log 1. So natural log of 1 is 0, so 4 times 0 gives us 0, so we're going to end up with just 4 natural log 13 as our answer. Okay?